All right, so we're excited to kick off our panel on the implication of SpaceX Starship on the competitive landscape. And joining me on the panel are Dr. Abhishek Tripathi, Director of Mission Operations at UC Berkeley Space Sciences Laboratory, and Dr. Andy Lapsa, CEO of Stoke Space. All right, so welcome. Let's start with you, Abby. If you could provide us a brief overview of UC Berkeley Space Sciences.
Yeah, UC Berkeley Space Sciences Lab sits sort of on the hill above the campus. We are currently managing and operating 3 NASA missions: Themis, New Star, and Icon. Although Icon is probably at the end of its life. We are also awarded 4 other missions that we're actively working on, NASA science missions: the Carruthers Observatory, Escapade, which is the twin spacecraft mission to Mars, COSY, which is a astrophysics observatory, and then MUSE, which we're doing in partnership with Lockheed Martin. There are several other missions we are in the running for also. So we went from a stage of doing a bunch of missions serially to being awarded a lot at once. We also make it a point to work with students as much as we can to make sure that they're ready to hit the workforce and all these space startups and NASA, of course, if they want to get a job there. We're trying to make sure we do a proper job of educating them. We also have startups come to us. We have a very mature mission operations team that is highly automated. So we've had startups come to us and ask questions about doing mission operations. In a few cases, even considering working with us to do the operations. Mm-hmm. So yeah, I think that's a brief overview, and we're excited about the future. We're excited about doing more missions for NASA and for others.
Amazing. And I had a chance to look at VSS's portfolio, and it really is quite massive. So a lot of incredible work that you're doing, both directly related to NASA as well as just general space sciences. Now, personally, from your background, if you could also tell us a little bit, because you're also a very active commentator on media, and I think you recently commented on the SpaceX Starship event just a few days ago, for instance.
Yeah, so just as a background, I worked, before I came to the Space Sciences Lab, I worked for 10 years at NASA's Johnson Space Center as a civil servant there. I then went on to work for 10 years at SpaceX in Hawthorne. I was a Dragon mission director. I was in charge of certification for all of their vehicles for the human spaceflight program, as well as the cargo program. So I'm definitely an observer and interested in the industry. I think, there are several trends, and I'm sure we'll get into the trends in an upcoming question. But I think, like everyone else, I'm very interested to see the Starship operational. I think it will be an inflection point with many regards. But beyond that, I'm also interested in seeing other types of unique, both launch vehicles and spacecraft come online. I don't think, anybody wants to be in an industry where there's only one player innovating. And so I'm always keeping an eye out on all the other companies doing great things.
Well, that is a great segue to Andy, who's going to give us an overview of Stoke Space.
Hi, thanks, Scott. So Stoke is looking holistically at space mobility logistics going to, through, and from space. The idea here is to build a space ecosystem that is both scalable and sustainable. And so for us, that begins with solving the 100% reusable rockets. We are designing them to fly, turn around effectively daily. And in particular, we're looking to solve the reusable upper stage problem, which to me is the last big domino to fall in our industry that unlocks another order of magnitude improvement in cost, in availability, and in reliability that really opens up a lot of the commercial business cases that have been proposed so far. So, very much in the vein of Starship, the ability to lower cost, to improve availability. This is the thing that's going to unlock our use of space for the good of the world and for our ability to scale our civilization.
Mm-hmm. So full reusability.
That's right. Full reusability, and not just the ability to be reused, but the ability to be reused at a very high frequency. So much more like the way we operate aircraft than the way rockets operate today.
Mm-hmm. All right. So I'm sure everybody's anxiously waiting to get your feedback, which is what's your thought on the recent Starship test? And do you think that SpaceX is spinning it from a marketing point of view, or you do feel that operationally, as essentially insiders, that it was actually very successful?
That question to me?
To both of you.
Loved it.
Andy,
Okay.
you can
Well,
feel free to take
sure.
it first.
Sure, I'm happy to take it. Well, let me first start off by saying that I'm a huge fan of Starship and what it brings to the business and the industry. I think, one thing that's very interesting is to date, before Falcon 9 came along, the commercial standard for cost was on an Atlas V and, something like $15,000 per kilogram. And today's rideshare prices on Falcon 9 are $6,500 per kilogram. So that's an order of, factor of 3 reduction thereabouts. And availability has gone up. And what this has done is created, there's over $100 billion of basically satellites that are in production or in work that need to get up. And all of that demand is new from the change that Falcon 9 has done to the industry. And I think that when Starship comes on, it's going to do that again, right? And it creates this whole industry that is now vibrant and needs multiple players to win. So I think that the success of Starship only helps the entire industry and helps us. So I'm a huge fan from that perspective. I'm also a huge fan as, a space geek. But I will say that, especially in early development, it's always a fine line between being efficient and scrappy and fast. I believe, and I think SpaceX has done a great job teaching our whole industry about the value of fast design and iteration, and the ability to, build things quickly at low cost and iterate and go quickly from that perspective. But at the same time, what we do has high consequence. It's dangerous. When we screw up, it fails spectacularly. And so there's some amount of, sobriety that you need to take and respect for the challenge. And I don't know, as an outsider looking in and, talking to some people on the inside as well, my personal opinion is that I think that particular launch was maybe rushed in certain ways that, they'll recover from and they'll keep going. But I personally think that there could have been a little bit more, for lack of a better word, diligence put into certain elements of that test.
Yeah. How about you, Abby?
Yeah, from my perspective, you hear about the very risky tests that SpaceX undertakes that went wrong. You don't hear about all the equally risky tests that they've done that actually turned out pretty well. Now, this was riskier on a greater scale in terms of affecting geography around it. I think I agree generally with what Andy said, which is, you have to walk a fine line, and sometimes you end up on the wrong side of that line. I think what really matters here is how much trust have you kept or eroded with the government people that you interact with, in this case, the FAA. If you were able to be straight with them and give them what you honestly thought was the risk, you're probably going to recover. The pad can be rebuilt. If there was miscommunication there, then this might end up being a larger deal than we understand from the outside. The one thing I kind of focused on was, the pad. If you look at the pictures that we've all seen on the internet, looked like it was pretty bad, and it could be that it takes a while to rebuild. But on the flip side, they got the Starship off, and they got a lot of really good data on the Starship. What if 6 months from now, the pad would have been ready to the satisfaction of everyone else, right? But the Starship would have failed within a minute of flight. Well, now you've lost 6 months of development time pursuing a design that was bad. So I think there's lots of different factors. What was good for the company? What was good for the geographical area? What's the relationship like now between the company and the FAA? A lot of factors, and it's hard for folks to just deconvolve all that. there are probably some pluses and definitely some minuses. So we just hope that they can recover and get on the right path again.
Okay. So
I think it's
yeah.
just to, I guess, agree with Abhi is, first of all, it is always a fine line, and it is hard even internally to deconvolve all of the factors at play, and you just have to make a judgment call at some point. And what you want to do, especially at tests at that scale, is maximize your learning as fast as possible. That's the conflict that we all have as, let's say as engineers, as chief engineers, as program managers. You're always trying to make that balance and find the right balance.
Yeah, absolutely. So let's talk about the current landscape. Again, Starship isn't in operation just yet, but let's talk about what's happening now, because I think it's important because, I think had it been any other launch company that tried to do what SpaceX was doing with Starship, I wonder if they would have been as successful and would they have had the finances. But let's get into the market dynamics in terms of what is the launch market looking like now? What are the opportunities and challenges that you're seeing firsthand?
Well, I think that the first thing is the landscape is that it is still by far a supply constrained market. There's a backlog, continues to be a backlog for launch. For example, Falcon 9 is launching. They launch mostly Starlink satellites. They do a handful of ride shares per year. You have Amazon Kuiper bought up basically all of the rest of the big launch. So that's through Arianespace, that's through ULA, and there's really nothing else, right? You have Rocket Lab's Electron vehicle at the complete opposite side of the spectrum, launching very small payloads, a couple 100 kilos at a time. And then there's really nothing operational that's in between those extremes, right? And so, look, there's a lot of projects that are out there right now, but they're not flying yet. And then I guess looking forward, how can they be cost competitive with not only Falcon 9 flying today, but also with Starship in the future? And I think that's where there's additional pinch points that are very important, right? So my personal belief, looking at cost models and understanding what it takes to launch things, if you are throwing your rocket away with every mission, I think that there's no way, even with mass production, that you can get payloads to orbit for less than $10,000 per kilogram, which again is already almost double what SpaceX is charging right now. And so the only way to be cost competitive and provide some advantages over what SpaceX is bringing is to go through 100% reusable vehicles and start flying at a very high cadence. And, obviously I have a biased perspective, but we are the only other company that's doing that. And I think that's powerful and important, and it's going to be a big market player.
Yeah, so I have a slightly different take than Andy on one part of what he said, but I completely agree with him that I think the future is 100% reusability. I was really happy when I saw that Stoke was going to try to reuse the second stage. I also think the future is more in larger rockets, even though the path to larger rockets for an individual company may be through smaller rockets. I'm not a big believer in small rockets. I think the one place where I'm still on the fence or slightly have a contrarian take to what Andy said is that I'm not convinced that yet that there is a market for a lot more capacity. I think the problem is not that we don't have enough supply of launch vehicles. I think honestly, like SpaceX can at any time turn on more supply if there's demand. I think there is a supply issue for foreign launches. So if you can't launch on a US rocket because of legal restrictions for your company, I definitely think you are supply constrained for sure. I think the reason backlogs are showing as high as they are for products that, like most startups, won't actually make it to market. So I'm not convinced that the backlog shown on paper is real. But I do think I do believe in market elasticity, and I do believe if more suppliers come on, we might have and thereby bring down price. I do think we might have more actual products that survive and make it to market, make it to launch, and we will need more supply of rockets for that. So I think the timing of my conviction is a little bit probably behind Andy's. I think it's coming, and I agree we'll be there at we will be there soon, but I'm not convinced we're there yet in terms of a lack of supply.
Yeah, because if what you're saying is correct, or phrased differently, is if in fact there is a supply shortage, then it should compensate from a market equilibrium so that the price comes up. I wonder if we're actually seeing that, or I don't think we're necessarily seeing a steep price increase per se. But to your point is that when we think about the SpaceX Falcon 9 that has a payload capacity of about 22,000 kilograms to LEO, versus SpaceX Starship that's going to have capacity of say 100 to maybe even 150 metric tons, that is significant. And again, whether we believe it or not, Elon Musk says that the launch price could eventually go to as low as $1 million to $10 per kilogram. Again, I don't know if it's just marketing or or tall tale, but that does definitely stir or encourage more demand stimulation. But let's talk a little bit about post Starship, and who are the ones that really need to get things up in space. We talked about those that are trying to create a constellation for broadband capabilities and so forth, but who are the others, and what's the business justification to send payloads into space?
Well, there's a number of them. I think that it also depends on the time horizon that you're looking at. By the way, just to respond to Abhi, I think I do have conviction that launch is a supply constrained market, especially in orbits and trajectories that are not LEO, right? And I think there are a number of demonstrated cases where companies are getting bumped from launch, can't get a spot on a Falcon 9, or the Falcon 9 is not available and going to a place where they want to go. And yeah, there's a lot of companies that are, or even governments that are kind of in a world of hurt and heavily delayed because launch is a constraint. Yeah, so in terms of the business cases and what kind of applications are going to space, the broadband internet is, first and foremost, that's the obvious one. We also have a number of satellites, and in fact, I think Starship or Starlink 2 or beyond are looking at direct to cell phone, right? So you will have direct connectivity to your cell phone worldwide. That's probably going to start with low bandwidth applications like text message, but eventually will be voice message. And, the ultimate holy grail is 5G or higher worldwide direct to cell, right? So that's one that there are a number of large constellation companies that are starting to go. I think you're going to start to see, I just heard the tail end of your prior call, which was that it takes an extra day to downlink data from space. I don't know what the application was, but the downlink from data from orbit to space is a pinch point. It's a natural physics pinch point, right? And so as we move more observation and more communication and more things into orbit, we're going to have to get very smart about what we actually decide to pull down. And so over time, you will see a massive amount of data being generated in space, but it will also have to be processed and handled in space. So those things will happen on orbit. So you're going to put more and more compute power on orbit. And then you're only going to beam down, let's say, finished products, right? That are highly refined. So you're going to start to see that. I think Amazon Kuiper is kind of designed in that model as well. I think, Starship, this is a post-Starship world in this scenario. And I think in that case, you will see, human transport become much more compelling, right? So now you will have commercial space stations that do all kinds of things. They'll do, hotels and recreation, travel, but they'll also do more research. They'll do, start to do, have legitimate labs doing material science, doing fundamental research, and also doing production of manufactured goods. So in that world, you're going to have a steady stream of not only human customers going to and from space stations, you're also going to have a steady supply of support goods and services. So things like food has to go there, trash has to go back, right? You have to do something with that. You have to supply raw materials and return finished products. You know, you're going to have more and more of that stuff become viable. And in that world, you need, direct service to that location and back. And that and back part is something that also hasn't been solved well by the industry, something that reusable upper stage vehicles can do naturally because they are coming and going in their natural course of business. So I think that's the next phase. In the long run, I think that, there's a lot of talk about lunar infrastructure, about mining asteroids and things like that. Frankly, that's a little bit far-fetched right now in terms of business case in my mind. But in a post-Starship world and in a world where we are coming and going to and from space with regularity and reliability and low cost, it's actually not that unreasonable. And I guess the analogy that I continually go back to in my head is all you have to do is rewind, 250 years, and our mode of transportation around the world is through tall sail ships. And in that world, it'd be unbelievable, be completely, ridiculous to think that you're going to outsource manufacturing overseas for, large scale goods and services. And today that's completely flipped, right? And I think the same things are true and the same market factors are true with space. So in the long run, you're going to see manufacturing, you're going to see energy production, you're going to see transportation, you're going to see communication. All of those things are going to be anchored in space.
Yeah. So again, we don't have too much time. We only have a few more minutes left. So I just want to make sure I frame this properly, which is that from an investor point of view, there are lots of adjacent and nascent space industries, whether it's satellite servicing, refueling, to private space stations and hotels, to the Artemis program support, including sending supplies to the moon, like you talked about as well, the cislunar economy, such as positioning, navigation, timing, and GNS, to a number of things that can happen. So from an investor point of view, what should we realistically believe will actually materialize in the next 5 to 7 years versus not? And how could Starship either help or not help some of these nascent industries? Abby?
Yeah, from my perspective, I look at Starship as a new train coming to town. So I look for businesses that I think are able to build off of that large mass and volume capability. And they're not going to be the only heavy or larger rocket. One of the companies I'm advising, Stoke Space Transport, is also looking to do something large. So I try to think of who's trying to compete directly with SpaceX versus who's trying to take advantage of some of the infrastructure that SpaceX is laying down. I'm a really big believer in going big. Take advantage of that mass and volume that is likely to come online. Another company I'm advising called K2 Space, they're working on creating the largest bus that will be available on the market to take advantage of the full 8-meter diameter. I think that part of the market is not as crowded. We have lots of companies making small satellites, right? In lots of countries, there's so many options, and it's hard to imagine that all of them will survive competing against each other. I think companies that have a clear business plan to take advantage of the mass and volume at the new price point are businesses that I'd be interested in as an investor. And I think there's definitely innovative things you can do. Just to put it in a simple perspective, the entire history of space exploration and space commerce has been, you need to shrink the thing to make it able to fit on the launch vehicle. You need to spend a lot of money to get the volume down, to get the power down, to get the mass down. I'm excited to have the script completely flipped, where now you can say, no, in order to make the thing cheaper, I get to use more mass. I get to use more volume. That's how I'm going to make it cheaper. And so I think companies that are articulating a vision of how to use that, those two new knobs are companies that I'm interested in as an investor and learning more about.
How about you, Andy?
I think that's 100% right in terms of, as availability and costs both improve, you have to stop super ultra optimizing your payloads, and that makes it cheaper. It makes it more available. Allows you to go through that iterative cycle. What I would say is you see this in every mode of transportation that exists, right? There's a spectrum of services that deliver the service, or spectrum of solutions that deliver the service. And scale is good as long as you can fill the seats, right? You are going to realize the minimum dollars per kilogram as long as you're filling each mission with the maximum number of kilograms. So, for example, in aircraft, you have a spectrum, everything from a Cessna to an A380, right? And on paper, A380 delivers, it's the most efficient aircraft, delivers you to your destination at the lowest dollars per kilogram effectively, right? But that's not the workhorse for the industry. The workhorse for the industry is a 737 or an A320 class aircraft, right? And that's because there's enough of customers who want to go to the same place at the same time to fill those seats. And I think you're going to see the same thing in space travel as well. The Starship provides something that is a freight train, right? It's great. It's needed to deliver and build some of this massive infrastructure, but that creates more demand across the rest of the spectrum. And I actually think that the optimal is not small. It's not 500 or 1,000 kilos. It's much bigger than that. But I think the optimal workhorse for the industry is something that maybe is smaller than Starship, right? Okay. It's hard to fill 100,000 kilograms of stuff in every mission.
So I'm going to ask my question again, just slightly differently, which is for investors that's trying to bet on not just launch startups, but also on space servicing and refueling and private space stations and hotels and other types of, let's say, cislunar capabilities. Where are the losers going to be and where are the winners? And again, I'm talking about kind of that 5 to 7 years, not 10, 15 or 20 years.
Yeah. Personally, I think that you hit a couple of the good ones. If you think about all of the things that have to be in place to make a thriving ecosystem in space, there's a lot of support infrastructure. So who is handling and telemetering the data? Who is doing the domain awareness? Who is doing effectively like the FAA's role, but in space, right? So who's doing the space traffic control, if you will? Who's doing GPS in a way that's better and more robust than our current assets, and who's doing it in the overall cislunar space so that we can now abstract away the complexity of tracking and navigation through space, right? So those things are very important. In terms of your supply chain and refueling and things and mobility, personally, I think that people are going to have an asset. They're going to want to deliver it to a service provider that gets it to the final destination in the long run. When you go to a UPS store, you say, this is the address I want to get to, and you don't care if there's a Sprinter van that first picks it up and drives it to the airport, and then it rides a 747, and then, right, you don't care about all that. You just want it to get to the final destination. So I think that's the natural end state of mobility. And I think things like orbital transfer vehicles will either be swallowed up by launch providers, or frankly, the moat is not that high on orbital transfer vehicles, so they'll just get replicated, right? And I think the big companies, at least in transport, are the ones who are thinking holistically about the end-to-end supply chain to deliver goods to final destination.
How about you, Abby?
Yeah, I'm interested. I agree with almost everything Andy said. I'm also interested in sort of the full stack Earth observation. I think too many people just collect data. I'm interested in the back end stuff, convert that data to actual intelligence that can then be used in many existing industries. I think there's a lot of potential there. And I also agree. I think there's going to be a lot of consolidation in the orbital transfer vehicle. I think, I look at Rocket Lab and I think to myself, wow, they're almost already a spacecraft company as much as they are a rocket company. And I think you're going to see more of that type of consolidation.
All right. So we're almost out of time. So real quickly, which launch companies do you believe will survive to compete with SpaceX, and which ones will go by the wayside?
Love to hear Abby on that one.
All right. So I will be honest that I don't believe that any small rocket maker right now, other than maybe one, will survive without announcing that they're going to have a larger rocket in their company's portfolio going forward. I believe that a rocket has to be fully reusable the way Stoke is. And I think in general, I would trend toward heavier is better. Okay, so without naming any specific companies, I will tell you that that's sort of my vision of where things are headed.
Andy?
I actually wholeheartedly agree with that. With the caveat of saying, I think there is a spectrum that will emerge in terms of scale, but the low end of that is, let's say, well above 1,000 kilos. So yeah, I think the small ones don't have a business case. I think if you're not fully reusable in the long run, you also don't have a business case. And I think that whittles the list down pretty tightly. Yeah, does that answer the question? I think maybe I would also say that this business and reaching a final solution is challenging. It's very hard. It is, quote unquote, rocket science, and it will take the right team, a very good team. It will take humility. It will take persistence. It'll take experience. It'll take the right thesis, and it'll take a pattern of execution. And that's very important. And there's a very small number of companies who have started to lay that out.
Great summary, Andy. I appreciate that. Well, I want to thank our panelists for a terrific, robust conversation on the implication of SpaceX Starship on the competitive landscape. Please give them a round of applause. I'll continue the discussion on space. We'll transition to space debris removal.